Now look into the OR sum. The probability distribution of a random variable x, where k is a constant, is given below. P of x is equal to x is 0.1 if x is equal to 0, kx squared if x is equal to 1, kx if x is equal to 2 or 3, and 0 otherwise. Now first let us draw the tabular form. X, P of x is equal to x. So starting with 0, it is 0.1. If 1, it is k. If it is 2, he says it is kx, so it is now going to be 2k. And 3, it is 3k. And 0 otherwise. Or let me put it as 0 otherwise. Like this. Yeah. Otherwise 0. Now you know the probability, the sum of the probability is 1. This sigma pi is equal to 1. So this infers 0.1 plus k plus 2k plus 3k plus 0 is equal to 1, or 2 plus 3, 5, 5 plus k. So when we add this, we get it as 2k plus 3k plus k is 6k, which is equal to 1 minus 0.1, or 6k is equal to 1 minus 0.1 is 0.99, or this implies k is equal to 99 by 600, which is equal to 33 over 200. Now, he says it is, he's asking you to find out. So we have found out the value for k is 33 by 200. So first part is being solved. K is equal to 33 by 200. Now coming to the second part, P of x lesser than equal to, P of x lesser than equal to 2. So P of lesser than equal to 2 is 0 and 1, which is equal to P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2, which is nothing but 0.1 plus k is 33 by 200 plus x is equal to 2. When x is equal to 2, it is 2k, that is 2 into 33 by 200. So that gives you, I can write the 0.1 as 1 by 10 plus 33 by 200 plus 66 by 200. So that gives me 200. So 20 plus 33 plus 66, which is nothing but 119 by 200. Next, the third part says, he's asking you to find out the mean of the variable x. Third part is mean the variable x, which is nothing but sigma x into P of x, which is equal to, so that gives you which is nothing but 0 plus 1 into k, which is 1 into 33.200 plus 2 into k, which is 2 into 2k, which is equal to 4k. So 4 into 33 by 200 plus 3 into 3k, that is 9k, that is 9 into 33 by 200, which is equal to 33 by 200 plus 4 3s are 12, 4 3s are 12, 132 by 200 plus 9 3s are 27, 9 3s are 27, 28, 29 by 200. So when added, that gives you 462 by 200, which is equal to 231 by 100, or which is equal to 2.31. So the mean x bar is equal to 2.31. Section B, 33rd problem. Solve the following system of equations by matrix method. X minus y plus 2z is equal to 7. 2x minus y plus 3z is equal to 12. 3x plus 2y minus z is equal to 5. Now I can rewrite this as 1 minus 1, 2, 2 minus 1, 3, 3, 2 minus 1 times x, y, z is equal to 7, 12, 5. Now clearly, the first 1 minus 1, 2, 2 minus 1, 3, 3, 2 minus 1 is a. So a is equal to, this is of the form a x equals b, where a is 1 minus 1, 2, 2 minus 1, 3, 3, 2 minus 1. Now, let us find the inverse of this particular matrix. So that gives you, first let us find out whether it is a singular matrix or not. Determinant value of A is 1 into 1 minus 6 plus 1 into minus 2 minus 9 plus 2 into 4 plus 3, which is equal to minus 2, which is not equal to 0. Hence, it is not a singular matrix. Hence, inverse exists. Now, let us look at get the cofactor of these elements. So, C11 is minus 5. C12 is 11. C13 is 7. C21 is plus 3. C22 is minus 7. And C23 is minus 5. C31 is minus 1. C32 is plus 1. And C33 is 1. Now, the adjoint of A is minus 5, 11, 7, 3, minus 7, minus 5, minus 1, 1, 1. Therefore, the inverse of the matrix A is A inverse is equal to minus of 1 by 2 into the adjoint of A, minus 5, 11, 7, 3, minus 7, minus 5, minus 1, 1, 1. Now we know A inverse of A into X is equal to, now pre-multiplying by A inverse on both sides. So this gives you A inverse of A is I. So Ix is equal to A inverse of B, or therefore X is equal to A inverse of B. So therefore X, Y, Z is equal to multiplying B with the inverse, A inverse, 11 minus 7, 1, 7 minus 5, 1 into 7, 12, 5, which gives you half into minus half into minus 35 plus 36 minus 5. Next is 77 minus 84 plus 5. The last one is 49 minus 60 plus 5, which is equal to 2, 1, 3. Therefore, x is equal to 2, y equals 1, and z is equal to 3. The OR sum. Obtain the inverse of the following matrix using the elementary operations. A is equal to 2, 1, minus 3, minus 1, minus 1, 4, 3, 0, 2. Let us first interchange R1 S and R1. I'll write R1. I'll interchange the first row and the second row. So this R1 and R2. So that will give you minus 1, 4. Oh, before that, let us equate this to, okay, let me write it as 2, 1, minus 3, minus 1, 4, 3, 0, 2 equals the unit matrix 1, 0, 0, 0, 1, 0, 0, 0, 1 into. Let us interchange the first row and the second row. So that will give you minus 1, 4, 2, 1, minus 3, 3, 0, 2. Same way, this first row will become 1, 0, 0, 1, 0, 1, 0, 0, 0, 0, 1 times 3. Now, we can take off the negative symbol from the first row, or R1 is minus R1. So, that will give you 1, 1, 4, minus 4, 2, 1, minus 3, 3, 0, 2 is equal to 0, minus 1, 0, 1, 0, 0, 0, 0, 1 into. Next is R2 is 2R1 minus R. So that will give you 1, 1, minus 4, 0, 1, minus 5, 3, 0, 2, which is equal to 0, minus 1, 0, minus 1, minus 2, 0, and 0, 0, 1. Next is 3R1 minus R2. R3 is 3R1 minus R3. So that gives you 1, 1, minus 4, 0, 1, minus 5, 0, 3, minus 15 is equal to 0, minus 1, 0, minus 1, minus 2, 0, 0, minus 3, minus 1 into 2. Next is R3 is R3 is 3R2 minus R3. That gives you 1, 1, minus 4, 0, 1, minus 5, 0, 0, minus 1, which is equal to 0, minus 1, 0, minus 1, minus 2, 0, minus 3, and 1. Now let us take the negative symbol from the third row. So I can write R3 as minus 1 times R3. So that will give you 1, 1, minus 4, 0, 1, minus 5, 0, 0, 1, which is equal to 0, minus 1, 0, minus 1, minus 2, 0, 3, 3, minus 1 times A. Next we'll do R3 is R2 is R2 plus 5R3. So that gives you 1, 1 minus 4, 0, 1, 0, 0, 0, 1, which is equal to 0, minus 1, 0, 14, 13 and minus 5, 3, 3, minus 1 into A. Next is R1 is R1 plus 4R3. That gives you 1, 1, 0, 0, 1, 0, 0, 0, 1, which is equal to 12, 11, minus 14, 14, 13, minus 5, 3, 3, minus 1 into 3. And finally, R1 is R1 minus R2, which is nothing but 1, 0, 0, 0, 1, 0, 0, 0, 1, which is equal to minus 2, 1, 14, 13, minus 5, 3, 3, minus 1. So this is nothing but A inverse of A is I. So therefore A inverse is equal to minus 2, 1, 14, 13, minus 5, 3, 3 and minus 1. 34. Find the points on the curve 9y squared is equal to x cubed where the normal of the curve makes equal intercepts with both axes. Also find the equation of the normals. So this interprets that 9y squared is equal to x cubed. Now differentiating on both sides, you get 9 into 2y into dy by dx is equal to 3x squared. Or this implies dy by dx at x1 y1 is equal to x1 squared by 6y1. Since it makes equal intercepts, the slope of the normal should be equal to slope of the normal is equal to plus or minus 1. Therefore, 6y1 by x1 squared is equal to plus or minus 1. If 6y1 is equal to, this implies 6y1 is equal to plus or minus 1 x1 squared. Or squaring on both sides, it gives you 36 y1 squared is equal to x1 to the power of 4. Or therefore, x1 to the power of 4 is equal to 36 x1 cubed by 9. Or from this we can get the value of x1 to be equal to 4. x1 is equal to 4. Now substituting this in equation 1, you get 9y1 squared is equal to 4 cubed, or this implies y1 is equal to plus or minus 8 by 3. Hence the points are 4, 8 by 3 and 4, minus 8 by 3. 35th question says, find the area of the following region using integration x, y such that x is lesser than or equal to mod x plus 2, y greater than or equal to x squared. So When you draw the graph, you get it like this, and the shaded region is the required area. Now let us find out the point of intersection. So I can equate x squared is equal to, when I take the positive value, mod x, since it says mod x, I can take a plus x first, plus x. So that gives you x squared minus x plus 2. So that gives you, when I factorize, I get it as x minus 2 and x plus 1. Now you can see it is symmetrical about x-axis. So the points of symmetry are now going to be, it is now going to be symmetrically cutting on both the sides. So I can find the area on one side and then multiply it by 2. So from this you can infer that x is equal to 2 and x is equal to minus 1. So the required area can be now taken as area is equal to integration of 0 to 2 x plus 2 dx. So I'll minus x squared dx. So 2 times, because since it is symmetric about x-axis, you can just find out on one quadrant and then multiply it by 2. So that would give you, when I integrate, that would give me 2 times x squared by 2 plus 2x between the limits 0 to 2 minus x cubed by 3 between the limits 0 to 2, or which is nothing but 2 into 2 plus 4 minus 8 by 3, which is equal to 2 times 10 by 3, which is equal to 20 by 3 squares. Now look into the odd sum. Using integration, find the area of the region bounded by the triangle whose vertices are 1, 0, 2, 2 and 3, 1. Now let us take the vertices as A 1, 0, B 2, 2 and C 3, 1. So area of the triangle ABC is equal to area of, so I can mark this as D, this as E. So area of triangle ABD plus area of the trapezium BDEC minus area of the triangle AEC. Now the equations with the sides, you can solve it and find out to be y equals 2 times x minus 1 and y equals 4 minus x and y equals half into x minus 1 respectively. That is the equation of the sides. This represents AB, this represents BC and this represents CE. So therefore, the required area, which is the area of the triangle ABC, is equal to integration of 1 to 2, 2 into x minus 1 dx plus integration of 2 to 3, 4 minus x dx minus integration of 1 to 3 x minus 1 by 2 dx. Now on integrating, you get it to be 2 times x squared by 2 minus x between the limits 1 to 2 plus 4x minus x squared by 2 between the limits 2 to 3 minus, let us take half outside, so that gives you x squared by 2 minus x between the limits 1 to 3. Now that gives you 2 into 2 squared by 2 minus 2 when you apply the upper limit minus the lower limit half minus 1 plus 4 times 3 when you apply the upper limit minus 3 squared by 2 minus, now applying the lower limit 4 times 2 minus 2 squared by 2 minus half into 3 squared by 2 minus 3 when you apply the upper limit minus applying the lower limit half minus 1. On simplification, that gives you 3 by 2 square roots. So the required area is 3 by 2 square roots. Now coming to the last question, show that the lines x minus 2 by 1 is equal to y minus 2 by 3 is equal to x minus 3 by 1 and x minus 2 by 1 is equal to y minus 3 by 4 is equal to z minus 4 by 2 intersect. Also find the coordinates of the point of intersection. Find the equation of the plane containing the two lines. So now we know the condition for two lines to intersect is x2 minus x1, y2 minus y1, z2 minus z1, L1, M1, N1, L2, M2, N2. The determinant value of this should be equal to 0, where L1, M1, N1 and L2, M2, N2 are the direction cosines of these two lines. So now substituting, x1 is 2, 2, 3 and x2, y2, z2 is 2, 3, 4. Now substituting, you get it to be minus 2 plus 2, minus 3 plus 2, minus 4 plus 2, 1, 3, 1 and 1, 4, 2, which is equal to 0, minus 1, minus 1, 1, 3, 1 and 1, 4, 2. Now on expanding, we can see that it is now going to be 0 plus 1 into 2 minus 1 minus 1 into 4 minus 3, or this implies 1 minus 1, which is equal to 0. Hence they intersect. Next, we have to find out the equation of the line containing these equation of the plane containing the lines is given by. Before that, we have to find out the points of intersection. Let us find out the points of intersection. Now to find out the points of intersection, let us now take the coordinates to be. Now let us equate x minus 2 by 1 is equal to y minus 2 by 3 is equal to z minus 3 by 1 to be equal to lambda, and x minus 2 by 1 equals y minus 3 by 4 equals z minus 4 by 2b equal to mu. So from this I get the coordinates to be x is equal to 2 plus lambda, y is equal to 2 plus 3 lambda and z is equal to 3 plus lambda. Same way, when I equate the other line, I'll get x to be equal to 2 plus mu, y equals 4 plus mu, 3 plus 4 mu, and z is equal to 4 plus 2 mu. Now, since the lines intersect, I can equate the x coordinates or y coordinates or z coordinates to find out the points. So, I'll equate the x coordinates that shows 2 plus lambda is equal to 2 plus mu, or this implies lambda is equal to mu. Substituting this for y, I get it as 2 plus 3 lambda is equal to 3 plus 4 lambda. In the place of mu, I am putting it as lambda. So, this implies lambda is equal to 2 minus 3, which is equal to 1. So, lambda is equal to 1. Now, we can find out the values to be x is equal to 2 minus 1, which is equal to 1. Y is equal to 2 minus 3, which is equal to minus 1. And z is equal to 3 minus 1, which is equal to 2. So, the points of intersection are 1, minus 2, 2. The coordinates of the point of intersection are 1, minus 1, 2. Now, let us find out the equation of the plane. Equation of the plane is x minus 2, y minus 2, z minus 3, 1, 3, 1, 1, 4, 2 is equal to 0. Now, on expanding, you get it as x minus 2 into 6 minus 4 minus y minus 2 into 2 minus 1 plus z minus 3 into 4 minus 3 equals 0, or 2x minus y plus z minus 5 equals 0, or this implies 2x minus y plus z minus 5 is equal to 0 is the equation of the plane.